Find where the following functions increase and decrease. Sketch a graph of A and B. So part A, what's the derivative? Let's figure out where this guy equals 0. So the derivative equals 0 when x is what? And how about where does the derivative not exist? Yep, doesn't happen. So the first thing we did was we found the critical numbers. That's what our last example is all about. Now we're going to draw a number line. And negative 5/2 is our only critical number. So if you want steps here, step 1, find your critical numbers. Check. Step 2, draw a number line with your critical numbers. Double check. Step 3, pick numbers on your number line. By drawing a tick mark at negative 5/2, we broke the number line into two sections. From negative infinity to negative 5/2, and where else? Negative infinity to positive. Actually, negative 5/2 to positive infinity. So from each section, we're going to pick a test number. So give me a number that's less than negative 5/2. Negative 3. And give me a number that's bigger than negative 5/2. 0. It doesn't matter what number you pick. 0 is very nice to work with. That's why it's a good idea to pick 0 if you can. Now, the other thing is, notice I used a different color. But more importantly, I used a different symbol here. So notice I'm using dots for my test numbers. And I used a line there for my critical number. So please, in your notes, do the exact same because you don't want to get this confused with the rest of chapter 13. The negative 3 and the 0, you're going to place back into the derivative. So above the number line, we're going to put the sign, S-I-G-N, either if it's positive or negative. So for instance, if we did f prime of negative 3, that would be 2 times negative 3 plus 5. What is 2 times negative 3 plus 5? You're fine. Negative 1. Is that positive or negative? Negative. So we're just going to put a minus sign above negative 3. And we'll do the same thing for 0. So what is 2 times 0 plus 5? 5, which is positive. So step 1, find your critical numbers. Step 2, draw a number line with your critical numbers. Step 3, pick some test numbers and determine their sign by plugging those numbers into the derivative. When the derivative is negative, the function is decreasing. So notice to the left of negative 5/2, any number you pick, you'll have a negative derivative. That's the point of a test number is you pick one, it works through everything. So where is our function decreasing? What interval is this? Negative infinity to negative 5/2. When the derivative is positive, the function is increasing, which is this section here. What values of x is that? Perfect. The reason I want you to choose either different colors or different symbols is when you go to write your interval notation for your final answer, you don't include the test numbers. So you don't want to say negative infinity and negative 3, because then you're lopping off all the numbers between negative 3 and negative 5/2, and that's bad. Okay, it's going to cause issues when we go to graph the thing. So once you get your signs, the test numbers no longer matter. You're only looking at your critical numbers, negative 5/2 or whatever we have. Okay? And if you think about it, the original function is a parabola, right? So, and it opens up because a is positive, right? And what we just found here is at negative 5/2, that happens to be the center of it. So as far as a graph is concerned, to the left of negative 5 halves, it decreases. And to the right of negative 5 halves, it increases. For our purposes, that's all we know. In the next section, we're going to learn exactly where this point's at. We can do that now, but we'll just wait until 13.2. Start off with the derivative of g. She was ready to go. 5x squared plus 6x plus 1. So if you would, determine where the derivative equals 0 and determine where the derivative does not exist. So how does 5x squared plus 6x plus 1 factor? 5x plus times, yeah. So looking at that, if you set those factors equal to 0, what do you get for x? Negative 1/5. Our derivative is what type of function? And the domain of a polynomial is all real, so where does the function not exist, the derivative not exist, excuse me? There you go. It's fun to say because it hurts. Okay. So what numbers are we putting on our number line? Yeah. So also be careful. Make sure you put the numbers in the right places as far as left or right. So I need a number left of negative 1. Negative 2. I need a number between negative 1 and negative 1/5. No. Oh. Yes. Negative 1/2. And bigger than negative 1/5. 0. So those three numbers are my test numbers, negative 2, negative 1/2, and 0. Where do I put those three numbers? Back into the derivative. The 5x squared plus 6x plus 1. So if you want to speed up the process, you could throw that g prime of x into your y equals, and then use the table function in your calculator. Because I don't need to see the math of where you got the signs from, I just need to see the end result. That way, it ensures that you don't make any numerical errors on your own, unless, of course, you put the function incorrectly into the calculator. So at negative 2, what do you get for the derivative? Positive or negative? Positive. At negative 1/2? And at 0? Positive. Comment, you should never, ever, ever get 0 for an answer. If you did, that means that these numbers are not correct. The negative 1 and the negative 1/5. Because those make the derivative 0. Your test numbers should not make the derivative 0. Okay, so that's a way of checking yourself. Okay, when the derivative is positive, the function is increasing. So where is the derivative positive? Negative infinity and negative 1. And then where else is the derivative positive? Very good. So again, once you've found those signs, you don't need the test numbers anymore. So that section there, positive. This section here, positive. And how about, oh, this is a whole mess of colors now. Hey, we got our secondary colors going on. This is where the derivative is negative. So that means the function is what? Decreasing. So what values of x are those? Negative 1 to negative 1/5. Is that okay? So here's negative 1. Here's negative 1/5. All we know is that it goes from increase to decrease to increase. That's what our number line says. And as we talked about earlier, there's 3 different shapes for increase, there's 3 different shapes for decrease. We don't know which shape it is, but if you think about it, the function's a cubic, so it's probably going to be something like Something like that. So we went from increase to decrease, back up to increase again. Yes. Right, so what's going to happen? Well, yes. As it's going to turn out, we're going to put the critical numbers back into the original function, and that will tell you the y coordinates. So we'll know exactly how high this point is and how high that point is. And then we're going to learn what shape to use. Which of the three increasing shapes do we use? Which of the three decreasing shapes we use? So as of right now, we don't know how to graph it.